Hello everybody, welcome back to mathematics class. This is very important video. Especially in the last video we discussed about how to remove the modulus notation when a composite function is given to you, right? And there are, especially we discussed about three conditions, three cases. One is only modulus of p of x, second one is modulus of p of x plus modulus of q of x is given to you. Then finally, how to remove the modulus from the notation, modulus of p of x plus modulus of q of x. So in this video we are going to discuss very important problems related to this concept. So please don't miss it and listen very carefully. So coming to question number 1. Solve the equation mod of x plus 5 plus modulus of x minus 1 which is equals to 7. This is clearly in the form of modulus of p of x plus modulus of q of x. So first we need to find out the intervals where they both are positive and where they both are negative by dividing into some intervals. So first of all, coming to solution, write the given condition. The given condition is modulus of x plus 5 plus modulus of x minus 1 which is equals to 7. Okay, so this is just like some p of x and this is some q of x. First of all, please equate them to zeros and find out the values of x. So on equating to 0, clearly I am going to get x is equals to minus 5, and after equating to 0, here we are going to get x is equals to 1. So this is the step number 1. First we need to equate the functions to the zeros and find out the values of x. Now what we got? X is equals to minus 5 and x is equals to 1. So now with the help of real number line, now clearly the number line should be divided into 3 parts now. So one is minus 5, say this is minus 5, and next one is 1, suppose this is 1. So now the entire number line is divided into 3 parts. Case 1, when less than minus 5, set of all values of x which are less than minus 5. And case 2, last one, the set of all values of x which are more than 1. I mean when x is greater than 1. And this is when x is less than minus 5. And third one is the middle interval, that is when x lies between minus 5 and 1. Okay. So since we have here 2 values of x, with the help of these values the number line can be divided into now 3 parts. Hence entire problem can be solved in 3 cases, right? So what is the case 1? So this is what case 1, okay, and this is the case 2, and finally this is the case 3. I mean all values when x is less than minus 5 and when x is greater than 1 and x when lies between minus 5 to 1. So coming to case 1, that is if x less than minus 5, x less than minus 5. So this is the part we are going to discuss here. So now when x is less than minus 5, we need to study the sign of x plus 5 as well as x minus 1. Okay, so as x less than minus 5, that implies I can write it that x plus 5 is less than 0. Isn't it? Just bring this side. X plus 5 is less than 0. Hence, modulus of x plus 5 is equals to, because of it is negative less than 0, which is equals to minus of x plus 5. Okay. Now, I need to study about this. So as x is less than 1, sorry, x is less than minus 5, isn't it? That implies, so if x is less than minus 5, then these are all, can we consider that less than 1 also? This set of numbers, nothing but less than minus 5, nothing but we get all negative values. Definitely all these negative values will be treated as less than 1 only. That implies x is less than 1. When x is less than minus 5, we can also write that x is less than 1. So from this, x minus 1 is less than 0. So that implies modulus of x minus 1, can write it as minus of x minus 1. Do you understand, ma? So here the case 1, that is when x is less than minus 5. When x is less than minus 5, now we need to study about its modulus value. Whether is it positive or it is negative. So this is what we need to check. So clearly, now this is the way we can write it. When x is less than minus 5, that implies if you bring this side x plus 5 less than 0, hence modulus of x plus 5 is equals to minus of x plus 5. And similarly, the values which are less than minus 5 are also less than 1. The meaning of less than minus 5 is nothing but less than 1. Hence x minus 1 less than 0 we can write it. So from this mod of x minus 1 is minus of x minus 1. So therefore this is implies. That implies what I can say now, therefore modulus of x plus 5 is equals to minus of x plus 5. And this value is also equals to minus of x minus 1, which is equals to 7. So from this we need to solve for x. So this is minus x minus 5, and before the bracket there is a minus, so that signs are going to be changed. Hence this is minus x and plus 1, which is equals to 7. Right? So from this minus 2x minus 4, which is equals to 7. Then minus 2x, if you send that side, then 2x is equals to minus 11. So from this what we got, x is equals to minus 11 by 2. So in case 1, that is when x less than minus 5, we got the value of x as minus 11 by 2. Okay. So if not, you can also think in generally also, not only using this fundamental concept, in generally also you can use. For example, here the case 1 is x is less than minus 5. You can use any number which is less than minus 5. For example, minus 4 I can take, isn't it? We can take minus 4. Now if it is minus 4, then definitely you see minus 4 plus 5, positive, plus 1. Positive means this is x plus 5. Minus 4 plus 1, no, not minus 4, no. What is there? Minus 6 we can take below minus 5 numbers. So minus 6, minus 7, anything. If you substitute minus 6 or minus 7 in this, you are going to get negative output. Then modulus of thing is negative, then output is negative. That is minus of x plus 5. Even here also, if you can substitute minus 6 or minus 7, then minus 6 minus 1 or minus 7 minus 1. Finally minus 8. Modulus of minus 8 is equals to minus of minus 8. That is minus of. So in generally, by choosing the number also you can discuss, not only in this manner. Now case 1 is clear, and we got x is equals to minus 11 by 2. Now we need to solve case 2. So what is the case 2 now? Case 2, that is minus 5 less than or equals to x less than or equals to 1. So this is the case now we need to discuss. In between minus 1, 5 to 1, including them also. Now in between this we need to study the modulus of x plus 5 is what? I mean whether it is equals to plus or minus. Similarly mod of x minus 1 is also whether plus or minus we need to. Can you think now what it is? So look at the case 2, that is minus 5 less than or equals to x less than or equals to 1. So I told you, no, if you are good, you can check it whether when x is less than 1, what about x plus 5 and x minus 1, etc, etc. If not, the simplest way is better to assume one of the value in between this. So minus 5 to 1, any one of the value you can assume it, either negative or positive. For example, let me want to assume 0. 0 is also one of the number, no? If x is equals to 0, then this is plus 5, so positive. That's why x plus 5 as it is x plus 5. And when it is 0, 0 minus 1, this is negative. Hence this value of x minus 1 is equal to, modulus of x minus 1 will be negative, minus of x minus 1. That is what the given condition we considered as 1. Therefore 1 implies, because of this is positive, remains as it is x plus 5. This is negative, then this could be minus of x minus 1. Now if you solve, see x and x getting cancelled, then finally what I got, 6 is equals to 7. But which never happens. That's what the meaning of existing of such a different condition is, nothing but there is no solution. Then coming to third case, that is, this is the case number 3, when x is greater than 1. Even here also, just you can assume any one of the number which is greater than 1. For example, let me want to take greater than 1 any value, 2, 3, 4, anything. Let me want to go with 3. Then 3 plus 5, 8, positive. 3 minus 1, 2, which is also positive. So because of the outputs are positive, they remains as it is. Modulus of x plus 5 is equal to x plus 5. Modulus of x minus 1 is equals to x minus 1. So finally, on solving, we are getting that x is equals to 3 by 2. So here we got in case 1, value of x is minus 11 by 2. Case 2, no solution. And case 3, x is equals to 3 by 2. Hence finally the required solutions are minus 11 by 2 and 3 by 2. So very important problems. These are for mains and advanced. So please go through the concept first of all what we discussed in the last class, so that you can easily understand what we are doing here. Right? So look at this, one more problem. Excellent problem this is. Can you read the question once? Solve the inequation mod of x minus 1 plus mod of x minus 2 less than 7. Okay. So as usual, coming to solution, first the given condition, assume it as equation number 1. Right? Now they are nothing but mod of p of x and mod of q of x. On equating to 0, here we get the value of x is equals to 1, and here we get the value of x is equals to 2. Right? 1 and 2. So hence divide the set of entire real numbers into 3 intervals. 1 and 2 now. Let us plot it on number line. Hence we got 3 intervals. Interval number 1, which is less than 1, x less than 1. This is the interval number 1. Okay. And now interval number 2, 1 and 2, in between 1 and 2 including them. Now interval number 3 is 2 to infinity, that is greater than 2. Right? So as per the rules and regulations of this type of problems, first we need to take the help of sign scheme where the p of x and q of x are positive and negative. So for that, first let us equate it to 0 and find out the values of x. So here we got it 1 and 2. So let us locate it 1 and 2 on the number line. Hence entire number line is now divided into 3 intervals. That is, this is the first one which comes under x less than 1. And this is the second interval, that is 1 and 2 in between, that is 1 less than or equals to x less than or equals to 2. And now x greater than 2, that is the third one, more than 2. Right? So since there are 3 intervals, hence the problem can be solved in 3 cases. And sometimes we may get maximum 3 solutions also. So coming to case 1, that is x less than 1, isn't it? Now when x less than 1, we need to identify whether modulus of x minus 1 is positive or negative. Similarly, x minus 2, modulus of x minus 2 is also positive or negative. As I told you, this is the as per the definition of mathematical definitions, as x is less than 1, after bringing the 1 I can write it that implies x minus 1 is less than 0. If x minus 1 is a negative, then modulus of its number is nothing but minus of. So modulus of x minus 1 is equals to minus of x minus 1. And not only that, if a number is less than 1, no doubt that which is also less than 2, isn't it? Because to study here, I want to know about x minus 2. So as x is less than 1, we can also write that x is surely less than 2. From this, after bringing the 2, x minus 2 is less than 0. So hence modulus of x minus 2 is equals to minus of x minus 2. So clearly what we understand in this case 1, this modulus of x minus 1 is minus of x minus 1. And modulus of x minus 2 is also minus of x minus 2. If not, you can also check it generally, as I told you, less than 1. Coming to less than 1, for example, you can assume any number. For example, 0 is the one of the number which is less than 1. If you substitute x is equals to 0 here, finally it is minus 1, negative. Hence output is also negative. And 0 if you substitute here, the same value you need to substitute in the both. Okay, then 0 if you substitute here, this is also minus 2, which is negative. Hence outcome is negative. So if you have the idea to check it in this manner, you can check. If not, you can also check with an example of by choosing any number which is belongs to this interval. Now finally, if you substitute these negative values in the first one, then modulus of x minus 1, I can write it as minus of x minus 1. And this is I can write it as minus of x minus 2, which is less than 7. Just on simplifying, we are getting minus 2x less than 4. Now I want to multiply with minus, then 2x becomes positive and plus 4 becomes minus 4. And immediately when we multiply with a negative, then inequality also gets changes. That is 2x greater than minus 4. Hence we got x is greater than minus 2. Actually there is a condition already here. There is a condition. What is this? X is less than 1. But we got one more condition that x is greater than minus 2. Hence we need to find the intersection of these two intervals. So please look at here, the number is 1 and here the number is minus 2. So since minus 2 is the smallest one, first you can look at minus 2 followed by 1. Now coming to here, less than 1 indicates which comes under all the numbers which are less than 1. Right now? And moreover, greater than minus 2. So which are greater than minus 2 are nothing but these are the things. Of course, these are not at all included. Now this is the intersection part, common solution. So taking the intersection of x less than 1 and x greater than minus 2 gives us what is the common solution is lies between minus 2 to 1. Hence the solution is here minus 2 less than x less than 1. Okay. So if you directly got it the answer here, no problem. If you got any another interval or any another inequality, then we need to take the intersection. Now similarly coming to case 2, that is 1 less than or equals to x less than or equals to 2. So here also we need to know about this modulus values, whether they are positive or negative. So let me assume any one of the value. I can assume it 1 also because equal to no. So for example, if I choose 1 is the number, 1 minus 1 0. I mean 0 is not a negative number, hence x minus 1 mod of x minus 1 is equal to x minus 1 only. And when x is equals to 1, the same number you need to substitute here also. 1 minus 2 which is negative, because of this is negative, output is minus of x minus 2. Now on solving this we got 1 less than 7, of course, which is extremely true, which is always true. Hence in this case, this is itself the solution. So 1 less than or equals to x less than or equals to 2. Now coming to case 3, that is when x greater than 2. When x greater than 2, once again you can assume any one of the number which is more than 2. For example 3. If I substitute 3 here, 3 minus 1 plus 2 positive. Hence mod of x minus 1 is positive, that is x minus 1. The same number that is 3, if I substitute here 3 minus 2 1, once again positive. Hence modulus is again positive, that's why as it is x minus 2. Now on solving here we got it x is less than 5. See, actually the condition is x greater than 2, but now we got once again one more condition, that is x less than 5. So now we need to take the intersection of these two conditions. So please note these numbers 2 and 5 on the number line. Case 1 is greater than 2. Greater than 2 is nothing but I think this is the region which is greater than 2. And case 2 what we got is less than 5. Less than 5, this is the region less than 5. So hence the common solution is, of course 2 and 5 are not included. So that's why open circle. Therefore what is the required circle is, the required solution is 2 to 5. So is 2 less than x less than 5. So 2 less than x less than 5 is the required solution. So most important problem, standard problem. So coming to next problem, solve the equation modulus of x square minus 2 mod x minus 12 is equals to 2 into modulus of x. So given that, what is the given condition? Just write down the condition as it is, that is modulus of x square minus 2 mod x minus 12 is equals to 2 into modulus of x. You know, this is in the form of modulus of a is equals to modulus of b. Then do you know how to solve this? If modulus of a is equals to modulus of b, can you remember the condition? What is the condition? That a plus b into a minus b is equals to 0. A plus b into a minus b is equals to 0. So if you go for a plus b, then what it is? X square. When you add this, plus 2 mod x minus 2 mod x cancel, then it's x square minus 12. After adding these two, minus term and plus term, these 2x and 2 mod x cancel. And what about a minus b is x square minus 2 into modulus of x and 2 into modulus of x. Finally 4 into modulus of x minus 12, which is equals to 0. Right? So this is what a plus b into a minus b is equals to 0. Now let us equate x square minus 12 is equals to 0. And one more thing is x square minus 4 into modulus of x minus 12 is equals to 0. So clearly from this, x square is equals to 12, hence x is equals to plus or minus root 12, actually this is, and root 12 we can write it as 4 into 3, no, that is 2 root 3. So in case 1 we got the solution that x is equals to plus or minus 2 root 3. Okay. Now we need to solve second one. Now what is this? X square minus 4 modulus of x minus 12 is equals to 0. Actually this can be solved in two cases, because here we have modulus of x. We don't know whether it is positive or negative. So case 1, let us assume that x is less than 0. Hence if x is less than 0, what I can say? Modulus of x is nothing but minus of x. Therefore, x square minus 4 into modulus of x is minus x, and minus 12 is equals to 0. And this is finally x square plus 4x minus 12 is equals to 0. So case 1, x is less than 0. When x is negative, modulus of x is equals to minus of x. So let us replace mod x is minus x in the given one. Hence this becomes now minus into minus plus. So x square plus 4x minus 12 is equals to 0. Clearly a quadratic equation. So just find out the factors. I want to write you directly the factors are x plus 6 into x minus 2 is equals to 0. So on equating to 0 we get x is equal to minus 6 and x is equals to 2. We got actually two values. One is x is equal to minus 6 and x is equals to 2. But here the condition is what? X is less than 0, isn't it? So since here x is less than 0, within these two which is less than 0, this is the value. Hence x is equals to minus 6 is the solution in this case. Right? Now go for case 2, that is non-negative. X is non-negative. To say non-negative, that is x is greater than or equals to 0. So clearly here modulus of x is equals to x. Now if you substitute in this modulus of x is equals to x, then this equation is nothing but x square minus 4x minus 12 is equals to 0. Okay. Once again, it is a quadratic equation. Go for factorization. The factors are minus 6 and plus 2. So then finally we get x minus 6 into x plus 2 is equals to 0. So on equating to 0, we get x value is 6 and another value of x is minus 2. But you know what is this here? In the case 2, x should be greater than or equals to 0. Means strictly non-negative. So within these two, what is the non-negative here? This is already negative now. Therefore, because of x greater than or equals to 0, in this case the solution is x. So clearly, my dear, in case 1, we got x is equal to plus or minus 2 root 3. And in this case, that is maybe case 2, that is minus 6. And finally here, plus 6. Therefore, required solutions are, what are the required solutions? Plus or minus 2 root 3, minus 6 and plus 6. Okay, so the main property to solve this question, which is this is. So first of all, when you look at this question, you need to identify that this is in the form of modulus of A is equals to modulus of B. And if you know the identities, that is the standard properties of modulus inequalities, then see how simple we can solve the problem. So modulus of A is equals to modulus of B, then the condition is A plus B into A minus B is equals to 0. So one way, this is the key step for this entire problem. So that is why I am asking you to please go through the modulus properties. I think nearly 16 properties we discussed in detail in the last videos. Okay, so please go through the properties of these functions, modulus functions especially, which will be very much useful to solve the problems related to this concept, that is how to remove the modulus notation when a composite function is given to you. Right? I hope you all understood this class. Thanking you.